Hi, hello. Today we're going to talk about how BGP update packets are sent across the wire and how it looks like. This particular video will talk about the session establishment that happens for a BGP protocol between the IXIA and the router. It's for the purposes of understanding how the control plane is set up, how the BGP is exchanging the route updates. Now the setup I have is very simple. I have an IXIA with an IP address of .100. This is the last ending octet IP, which is talking to a DUT router, in this case Juniper, which has got an IP address of .2. And we are running BGP between the IXIA and the router. There's already a lot of videos on the channel that explains how to configure BGP on the IXIA towards a DUT router. You can refer to that if you would like to know how to configure BGP. Now going further on this IXIA is going to send 10 routes towards the DUT, and the route update direction is from IXIA towards the router. Now quickly jumping into the IXIA itself, you can see that I have the Ethernet stack IPv4 BGP. The session is up. The BGP routes that I was referring to are the 10 routes are starting from 200.10 to 200.19. Now we will go quickly into the Wireshark packet trace to identify how the packet looks like. So here, as we were referencing, before the BGP is starting, what really happens, as you can see, is there is a three-way handshake. Now we know that you have to look at the frame number 4, as you can see here. Frame number 4 is the one that is generated by the IXIA, because .2 is the IXIA. It is trying to establish a three-way TCP handshake towards the Juniper router. So that is the SYN packet. Then the Juniper router, in this case frame number 5, is responding with a SYN ACK. And finally you can see that the IXIA, which is frame number 6, is sending back an ACK. Now once the three-way handshake happens, the BGP open messages are used to exchange BGP related information in terms of their capabilities and parameters, as I am displaying here. You can see that this particular frame that we are looking at is frame number 7, which is again sent by the IXIA towards the router in frame number 7, and you can see it's displaying all the capabilities. You can see AFI, address family identifier, and it is telling that it can support v4. Likewise, it is also giving you details about all the capabilities. Now you can look for further details on the capabilities. You can see, for example, the IXIA is also saying that it is capable of supporting AFI for IPv4 VPNs, which is with the sub identifier. So the AFI for IPv4 is still 1, address family identifier for v4 is 1, subsequent address family identifier for IP VPN, so which is INET VPN terms, you can see it is clearly saying it is 128. So because the IXIA has all these features turned on, it is pretty much trying to negotiate on the open message with all these values. You can see for IPv6 the address family identifier is version number 2. So AFI for IPv4 is 1, AFI address family identifier for v6 is 2, and subsequent address family, for in this case multicast, it's also trying to negotiate all these capabilities. So frame number 7 is from IXIA. Now let's look at the frame number 8 from the router. What are all its capabilities on the open message? So on the router's open capability messages, you can very clearly see that it is saying it can support IPv4, and subsequent address family identifier is unicast, so IPv4 unicast. And then you can see it is also trying to say what is all the other capabilities it can support, route refresh capability, and also it can support things like it is giving me the local AS number and whether I support 4-byte octets. So very handy, this particular way of decoding BGP to understand what happens. Now after open messages are understood and they establish the session based on the capability, the sessions are maintained through keep alives. You can see keep alives being sent, and the most important part is frame number 12. You see the router, in this case, in addition to sending keep alive, it is also sending an update message. In the update message, it's pretty much sending me a marker because the router does not have any updates to send. But let's look at an update message from the IXIA itself. So .2, as we know, is the IXIA. It's sending it to .100. And within the update messages, you can see it has got the NLRI, which is network layer reachable information, and you can see all the prefixes that it is advertising, including the path attributes. And you can see all those prefixes are here. So hope you find this useful. Bye for now.